Hi guys, today we're going to look at stretches and enlargements, and I'm going to do this by considering what happens to the unit square. Now the unit square is this square here that crosses the axes at 1 in both places and meets there at 1, 1. So you can see the 4 points on the unit square are 0, 0, 0, 1, 1, 0 and 1, 1. So all I've done is I've taken their 4 position vectors and put them all together in a single matrix, because then I can work as a whole, and it's something I spoke to you about before. Now I'm going to start off with a matrix of this 3, 0, 0, 1, and when I times 3, 0 by 0, 0, I get 0. And when I times 0, 1 by 0, 0, I get 0. So under this transformation, 0, 0 goes to 0, 0. And remember, that's a particular feature of a linear transformation. So we know that this is linear because 0, 0 has gone to 0, 0. Now if I've got to take the point 0, 1, 3, 0, so 3 times 0, 0 times 1 goes to 0, that stays the same. And 0 times 0 is 0, 1 times 1 is 1. So that one has stayed the same too. Now if I'm looking at the next one, I've got 3 times 1 and 0 times 0, so that's 3. And I've got 0 times 1 and 1 times 0, which is 0. So these ones here have been times by 3. Now looking at the final one, 3 times 1 and 0 times 1 is 3, and 0 times 1 is 0, and 1 times 1 is 1. So I think you might be able to see that when I join these points together, I've got 0, 0, 0, 1, 3, 0 and 3, 1. I end up with this rectangle. And so what I've done to my original unit square is I've stretched it. So this matrix here has given us a stretch parallel to the x-axis with a scale factor of 3. Now for my next one, I want to do 1, 0, 0, 4. So we get 0, 0. 1, 0 times 0, 1 is 0. 0 times 0 plus 4 times 1 is 4. That stays at 1, 0. And this comes to 1, 4. So those points are 0, 0, 0, 4, 1, 0 and 1, 4. So my unit square has now become a rectangle up here. So this has been a stretch parallel to y-axis scale factor 4. Now I can of course change that. So I've done x by changing that, I've done y by changing that, x changes that one, y changes that one. So I can just change them both if I want to. So I've got 0, 0. Remember, this one will double the x's, and this one will times the y's by 5. 0, 5, 2, 0, 2, 5. So I've got 0, 0, 0, 5, 2, 0, 2, 5. So my unit square has been stretched parallel to X, scale factor 2, a stretch parallel to Y, scale factor 5. Now, if I make both stretches the same, so let's say we went 6, 0, 0, 6, so then I get 0, 0, 0, 6, 6, 0, 6, 6. So I end up here, here, and I have to use my ruler to help me with this one, and here. My unit square becomes another square, but this time, because it's stretched in the X direction, same as the stretch in the Y direction, this is an enlargement of scale factor 6, centre at O. So these are like the form of the identity matrix, and that's really where it stems from, the 1, 0, 0, 1. So changing this number alters the x's in the identity matrix, changes this number alters the y in the identity matrix, changing them both enters the x and the y, but if I change them both by the same amount, then it's an enlargement. And be sure to put all the details down. So stretch parallel to the x-axis, stretch parallel to the y-axis, enlargement scale factor 6, but important to put down that it's where the centre is. And although all the centres are going to be the same, it's still important that you know what's happening mathematically and you are showing that to your examiner. Okay?